This example has factors that are repeating that aren't linear. So we'll get the setup going. So you can look at the denominator. The denominator is already factored. You might notice the numerator is a little long. That's okay. And we'll set this up. So it's going to be something over x. Now, x is a linear factor, so it's just going to be a constant up there in the numerator, a, plus, and then we're going to have our other factor, x squared plus 1. We'll just have it one time down there. Now that factor is not linear, so it's a degree 2, a second degree factor. So we have to make it a linear factor in the numerator, and that requires us to have an x term and a constant. So it's going to be bx plus c. And then finally, at the end, we'll have that quadratic factor, but it's repeated, so we'll have it squared. Now, it's still a quadratic factor, so we're going to have a linear factor in the numerator, which is going to be dx plus e. So we're up to e on the alphabet. Don't let the size of this scare you. Sometimes these actually work out easier than some of the other ones. But okay, so we're going to have x to the 4th plus x cubed plus x squared minus x plus 1. I want to write those terms out so that when it comes to the matching, I can find those easily. Equals a times, and that's going to have to be x squared plus 1 squared. Plus, and then I'm going to have my bx plus c, that numerator. I'll have to multiply it by x, and I'll also have to multiply it by a factor of x squared plus 1. So think about that for a little bit. Again, we're trying to get those common denominators here is what we're trying to do. We're just looking at the numerators. We know what the denominator is, but we don't care. Okay, not right now. Okay, so then our last one is going to be the dx plus e times just x is missing there. So you've got the x squared plus 1 squared. So you've got everything except the x. Okay, so now it's going to be a bunch of multiplying here. We're going to have a times, and I'm going to square that binomial. It's going to be x to the 4th plus 2x squared plus 1. And then, now how am I going to factor or multiply this out? I'm going to distribute the x that's in the middle there. So I'm going to distribute this in like that. So I'll have bx squared. There comes that little blue box that I wish wouldn't happen. Anyway. Okay, bx squared plus cx times x squared plus 1. So we'll still have to multiply that out. And then the end, we can distribute the x. So dx squared plus ex. Okay, so let's continue with the multiplying. We're going to have a x to the 4th plus 2ax squared plus a plus, and now I'll have to, it's a binomial times a binomial, so I'm just going to FOIL this out. It's going to be bx to the 4th plus bx squared plus cx cubed plus cx. You can think about that with the foiling and everything. Plus dx squared plus ex. Whew, that's a long one. Okay, now comes the matching up. I'm going to run out of colors here, but I'll use what I can. So I'm looking at, I just start at the beginning with the x to the 4th. So I need 1 to equal, now what do I have for x to the 4th? A plus b, just those two terms. Okay. Now I'm going to go to the next one, which is a coefficient of 1. And I'm looking for any x cubed terms. I only have the one x cubed term right there. So 1 is going to equal c. That means I know what c is. Yay, I've got one of the variables, because I've got to find 5 variables, a, b, c, d, and e. But I know what c is. All right. Now let's go to the x squared. Again, it's a coefficient of 1. And who's an x squared? Well, 2a plus, I'm pretty sure there's another one at least, b plus d. And those would be all the x squared terms. All right, purple, -1. Notice that you have to pay attention to that negative coefficient there, so -1. And now I'm looking for any x terms. I've got a c plus an e. And then my last one, I'll use red, but 1 is equal to, and I think I've got all the terms except for that one, a, which means I know what a is as well. So knowing what c is and knowing what a is, that's really going to help. Because we know what a is, we can go back to the first equation and say 1 equals, what was a? 1. So b must be 0. And you might think that's odd to get a 0, but it happens. It's not uncommon for it to happen. It's okay that we got b to equal 0. You'll notice what happens when we go to write the answer. But we got that now. Okay. Now we know a and b, so we can figure out, we can go to this blue equation and figure out d. So 1 equals 2 times 1 plus 0 plus d. So what's that going to be? A 2, and if I subtract it, -1 equals d. And then is that everything? A we know, B we know, C we know, D, oh, we don't know E. Okay, so we got to figure out E. C was also 1. So it looks like E is going to be -2. Okay, now what I have to do is I have to follow this right there. So I have a over x, it's leaving me. I have a over x, which is going to be 1 over x plus, and then it's going to be bx plus c. Well, that's going to be a 0x plus c, which was 1, over the x squared plus 1. I wouldn't put the 0x, I would just leave it out, but I'll do that in the next step. Plus, and then d was a -1x. D is -1, but it was dx, so -1x, and then e was -2. Now, I'm going to show you how the book writes this, just so that you can see it in case you ever had any questions about it. But they're going to write 1 over x, 1 over x plus 1 over x squared plus 1. They probably wouldn't put the parentheses there, but you could. And then in the book, they factored out the negatives there. So they made it minus, and that's going to make it x plus 2 over x squared plus 1 squared. I wouldn't care if you made it plus -x minus 2, but just so that you know they can do that. So that's the answer there.